Hey everyone, this is a video on matter, elements, and atoms. This is I would think a good preview before learning more on atoms and just the chemical structure. Now, the quote I like here is, "You're living, you occupy space, you have mass, you matter." Kind of playing with words. Now, let's get to the topic. So we'll quickly go through some of it and we'll go through all of them. Matter, element, atoms, components, these components. And again, this is going to be brief, but hope informative for you. So, what is matter? The definition is given by Wikipedia is that in the classical physics observed in everyday life and no knowledge book, everything from the sciences, chemistry, biology, physics, especially are all very closely related, and math, of course. So, in the classical physics observed in everyday life, matter is any substance that has mass and takes up space. This includes atoms and anything made of these, but not other energy phenomena or waste, such as light or sound. So, what are your thoughts on the term matter? Actually, going back to going back to the quote, "You're living, you occupy space, you have a mass, you matter." This is one of the definitions, or pretty much anything that occupies space. Wikipedia is a very good definition. It gives you a definition that you need to know. So yes, anything that occupies space. And the substances, the matter gets into substances called elements. And this is a clear example of the structure of elements, the periodic table. And elements have chemical and physical properties which cannot be broken into other substances through certain reactions. So, for example, we have gold. Where's gold? We have, let's say carbon first. We have carbon as an element, and also carbon as a compound. Same goes with our gold. I'm not used to seeing colored here. Gold first. Now, most of these elements are exist in the natural world, in our world, and some of them, well, out of 118, I think 92 are naturally existing, and the rest are made or tested in labs, made in labs, and they're not as stable because they're not inserted into real life. And another thing that I would like to also mention is that elements name, so you see carbon here is the first letter or the first two letters. For example, aluminium are the way that they're written, so carbon C, aluminium Al, and capitalized letter, of course. And most of them come from Latin words giving different definitions and terms. Another thing is to know is that there are 4 elements which are common to all organisms, and 96% of human body is made out of oxygen, nitrogen, hydrogen, and carbon. So these 3 plus 1. And non-living organisms have elements used in different proportions, and some are rare, but these 4 are common to many organisms. Now, as I mentioned earlier, all elements undergo the chemical and physical reactions and physical laws, regardless if they are a part of living or non-living world. Now, I would advise you to watch a Chem Academy video. I shared in SlideShare this presentation. I'm putting the link to Chem Academy video below, also in the description. But if you can also see the link in the SlideShare on the SlideShare website. Now, moving on to atoms. So that was about elements. Moving on to atoms. Another term from Wikipedia, and I'm going to be using Wikipedia a lot because I figure this is it would be nice to have terms defined by one resource. And we'll see if you like it. Yeah, please just inform me if you like it or not, or which sources would you actually advise to with the citations. Now, what is an atom? The definition for Wikipedia is an atom is the smallest constituent unit of ordinary matter that has the properties of a chemical element. Now, yes, that's pretty much the term. So, smallest unit of matter that remains chemical properties of an element. And this is the atomic structure, so you see how it looks. And pretty much, if we take a gold coin, so I mentioned gold as an element earlier. If we take a gold coin, it is pretty much consists a large number of gold atoms in a coin shape, and atom gets its properties of what it consists of. So as here mentioned earlier, proton, neutron, electron, and we see them here. So another one, this is a nucleus, also a term that I haven't observed in there, but it exists. So the atom gets its properties of what it consists of, and there are two regions. So the nucleus, it consists of protons, positively charged particles, and neutrons. They don't have any charge. Now, the second region is this so-called cloud of mass, which are electrons. Oops. So these are electrons, and there are, again, it's mentioned everywhere. They don't look like these. Those are not like clear orbits as in space, like the Earth is going around the sun, but it's just buzzing and very complex. But this is a way of presenting it so that the human mind can understand it more or less. Otherwise, it gets too complicated. So why is this holding on together? So we know that positive attracts and negative charges attract to each other. So we have positively charged protons, negatively charged electrons, and neutrons. So this attraction, sort of a bond, holds the atom together, so makes it a whole. And most atoms contain all three types of these subatomic particles. They're all called subatomic particles: electrons, protons, and neutrons. And hydrogen is an exception though, because it has one proton, one electron, but no neutrons. Now, to keep in mind, very important, is that, and again, there is more in Khan Academy. This subject is more discussed, but proton, this positively charged guy, red one here, it defines the element, and number of protons equals the number of atomic number. It shows which atom that we're looking at. So if we look at, say, titanium, 22, number 22, meaning that there are 22 protons. And the electron, negatively charged on blue here, defines the reactions the atom undergoes under. So we'll talk about it actually later, because sometimes the electrons and protons are not going to be the same number. So if the electron leaves, these are the only guys that can actually leave, or come here. There can be more electrons or less electrons, and this depends on the bonds that you will have, the net charge that you will have, the ionic bond, and it will actually give you a certain substance. It will give a characteristic to a certain substance or structure or a function to it. I hope this is not too complex the way I explained it, but the electron defines the reactions that the atom undergoes under, and we'll talk also more and more about. Okay, back. Keep in mind another thing. This is from the Khan Academy article. So protons, neutrons, and electrons are very small, and most of the volume of an atom, which is greater than 99%, is actually empty space. So this is pretty much empty space. So it's not kind of that all tight, close looking. Um, and with all this empty space, you might ask also why so-called solid objects don't pass through one another, and the answer is that the negatively charged electron clouds of the atoms will repel each other if they get too close together, resulting in our perception of solidity. So if they meet other atoms, electrons, they will just not get messed up together. And again, depending on their quality, you can also know more about the reactions they undergo. And also, I in school, I remember I really liked this part, like the empty space. That there is pretty much an atom is quite empty. So meaning that everything that atom composes is empty. The elements are empty. The compounds are empty. The cells are empty. The organs are empty. We're made of organs, so we're all an empty space. I know that sounds ridiculous, but I love to mention that at school time to time that if an atom is mostly empty, then everything around us and the whole universe is an empty space. Well, another way to look at gratitude or greatness of biology and chemistry. Here are the references I've used: Wikipedia and Khan Academy. Please also make sure to look at the SlideShare. I've shared the link below. And actually, there you go. Here's the SlideShare, LinkedIn, and the LabGirl group. Thank you very much. Have a great day. Thank you for watching it. Bye.